Hi, my name is Jennifer, and in this video, I'm going to show you how to simplify cubed roots and higher. So grab a pencil and some paper and work through these examples with me. Take a look at our first example. We have the cubed root of 40. To solve this, we're going to take the expression 40 off to the side, and we're going to make a factor tree. 4 times 10, we can break our 4 to 2 times 2, and our 10 breaks down to 2 times 5. You need to just make sure this bottom line, 2 times 2 times 2 times 5, still equals 40. Now, because this is a cubed root, and we know it's a cubed root because of the 3 sitting right here next to the radical, we're looking for numbers in groups of 3. So for example, we have 2 times 2 times 2. There are 3 2s, so we could actually call it triplets, a set of two triplets. So here's how we're going to write our answer. We're going to represent our set of triplets, our set of 3 2s, on the outside of our radical. Next, we're going to draw our radical symbol. Don't forget to put the little 3 to represent the cubed root. And any number that did not have a set of 3 goes on the inside, which is our 5. So our final answer is 2 cubed roots of 5. Let's do another problem. This is the cubed root of 24. We'll take the number 24 and we'll make a factor tree. We have 6 times 4. We can break apart 6 as 2 times 3, and 4 breaks into 2 times 2. Next, because this is a cubed problem, we're looking for 3 of the same number. Even though they're not sitting next to each other, we can still consider that this 2 can be paired up with those 2. We can call that we have a triplet set of 2s. Now, when we write our final answer, we're going to represent this set of 3 2s on the outside of our radical by putting 1 2. Next, we'll draw our radical symbol, put in our cubed number, and any number that did not have sets of 3 goes on the inside. Notice that the 3 did not have 2 other 3s, so it's going to stay inside the radical. So the final answer to this problem is 2 cubed roots of 3. Okay, next, let's look at this problem. This is the 4th root of 32. So we're going to do the same thing, except this time we're going to look for groups of 4 at our bottom line of our factor tree. We're going to take 32, breaks down to 8 times 4. We can break the 8 down to 4 times 2. And this 4 breaks down to 2 times 2. And we'll bring that 2 down. This 4 also breaks down to 2 times 2. And we need to bring those 2 down to the bottom. Next, because it's a 4th root, we're looking for numbers that are in groups of 4. Or we could say quadruplets. 2 times 2 times 2 times 2. We have at least 4 2s. Now for our answer, we're going to represent this set of 4 2s on the outside of our radical with a 2. Next, we'll draw our radical symbol. We'll put our 4th root in, and any number that did not make it into a group of 4 stays on the inside, which is this 2. So our final answer is 2 4th roots of 2. Okay, let's do one more problem together. This is the 4th root of 162. So we're going to go ahead and make a factor tree of 162 and then see if we have any number, we have 4 of the same number. 162 can break down to 81 times 2. 81 can break down to 9 times 9, and each of those 9s can break down to 3 times 3. And then we'll also bring this 2 down to the bottom line. Next, because this is the 4th root, we're looking for any number that is in sets of 4. Notice that we have 4 3s, or we have a quadruplet set of 3s. So to represent this in our answer, we'll put a 3 on the outside of the radical, representing our group of 4. We'll put our 4th root symbol, and any number that did not have a set of 4 stays on the inside, which is this 2. So the final answer is 3 4th roots of 2. If you have any questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.